So this is Stickybot 1. This is our very first gecko-inspired robot. And there's a couple differences with this robot. One is that it has just 3 degrees of freedom per leg. There's 1, 2, and the third is the curling mechanism, which I can't do manually. So that's 12 motors on this entire robot. This robot, on the other hand, has 16 motors on it. So it has 1, 2, 3, 4. 4 different motors per leg, so it's a lot more motors. Another thing that this robot does that the previous one couldn't do is rotate its ankles around. The first robot could climb straight up, and it did that by having all of its feet oriented directly facing upward. But if you wanted to point some other direction, what you would need to do is rotate the other feet around. These bottom feet actually have to turn all the way upside down, and it has to pull in. So this robot has fixed ankles and can't rotate and do that. So this is also a much lighter robot. When we first built this robot, we weren't sure how the adhesives were going to work. So we very much designed them trying to match what a gecko would do. And when a gecko feels to detach, but these new ones, all you have to do is unload them. It turns out we didn't know that, so we've really changed the design of how the robot works. This one was very light and had this peeling mechanism because we didn't know how the adhesives were going to work. When we started this one, we knew exactly how the adhesives were going to work, so we allowed it to become heavier, and we have those rotating feet, and we know all we have to do is just lightly load.
Can you explain the adhesives a little bit?
So,
Have you seen the climb? Watch it's going to climb. Is it going to climb?
the adhesives have these small microscopic hairs on the feet. They're invisible to the naked eye, and they're directly inspired by geckos. Geckos also have these tiny microscopic hairs, but theirs are much, much smaller than ours, much longer than ours, and they're much stiffer. All of these 3 properties allow the gecko adhesive to climb virtually any surface that we have. We're limited in our adhesives because we have relatively large hairs, relatively soft hairs, and relatively short hairs. But one thing that it does that mimics the gecko is when you pull down, you increase the amount of adhesion. So all you have to do is just lightly put it into the wall and let its weight pull and load the feet, and it sticks. And all it has to do to release the foot is just lightly push up, and it pops off without any problem. This is very different from a piece of tape. If you have a piece of tape, you actually have to press into the surface in order to get it to stick. And then once it's stuck, you have to pull really hard to get it to pop off. The gecko doesn't do that. The gecko can very easily put its foot down, adhere strongly, and then detach.
So what are you working on now, and what's the future for this robot?
So this robot has yet to climb for the first time reliably, and it's a brand new robot. It's almost never been seen before. In fact, you won't even find it on the internet.
Well, you will now.
Yeah, that's fair enough. It's fair enough. And so right now we're just getting the programming down, and we're getting some of the mechanical adjustments down. Right now we're having difficulty matching orientation to the wall and to get just the right forces. Once we solve these problems, we'll be able to climb upward. And then once we do that, then we can start to do experiments by rotating these feet around and starting to see what happens when we start generating these pull-in forces.
And how is it with climbing on surfaces that aren't smooth?
So, beyond the smooth surfaces, these adhesives are not really designed to climb those surfaces. These adhesives are really designed to have smooth surfaces and slightly rough surfaces. Anything that's glossy, it does well on. Rougher than that, it doesn't do so well, and that comes back to the geometry of the shapes. We've really hit the limit of how small we can go with our current technology. So we're actively looking for new technologies to get smaller and smaller features. And the smaller we go, the better we'll be able to do. So if we find technologies that let us make these new adhesives, we can then try to climb really challenging surfaces.